So good morning everyone. I am Itisri Misra. Continuing with the Thermal Engineering 2, that is your 4th semester course. So today we will discuss about your chapter 5, that is your what? That is your vapor power cycle. Okay. So in this chapter what we will discuss what is Carnot cycle, what is the efficiency, what is Rankine cycle, what are the efficiency, what is reheat cycle, what is regenerative cycle, and we will discuss various end effect of reheating, lowering the condenser pressure, increasing the pressure, boiler pressure, that we will discuss. Okay, then first we will discuss this vapor power cycle is used in where? In the steam power plant. So that vapor power cycle or steam power cycle. The vapor power cycle are used in the steam power plant. And where? What is the function of the power cycle? The power cycle means which will be convert the heat energy into work. So here what will happen? The burning of fuel is converted into what? In the work. Which from where you get the work? We get the work from turbine. So in the boiler we are giving the heat. So when you are giving the heat to the boiler, so inside the boiler the water will be converted to what? Steam. So when the steam will be expanded in the turbine, then we got shaft work, that is your turbine work, and some of the steam will be escape from the turbine and it will be sent to the condenser, where condenser reject the heat of the exhaust steam and become liquid, and this liquid will be sent to the boiler through the pump. This is the cycle of operation of what? Vapor power cycle. So here what is your working fluid? Working fluid is your water. Working fluid is water. From here in the pump and the boiler there is your water, in the turbine and condenser there is your steam. So what will happen? Heat will be transferred to the water in the boiler. How much heat will be transferred? It will be transferred Q in amount or QH amount of heat will be transferred to the boiler from the source temperature TH, and QL amount or Q out amount of some of the heat will be rejected, that is Q out or QL, to the sink, and we get the work. So the one cycle will be completed. So if you have to using the first law of thermodynamics to find out the efficiency, we know that from the first law of thermodynamics for a cycle, for the cycle is net work done is equal to net heat transfer. So what is your net heat transfer? Net heat transfer, heat will be supplied QH, heat will be rejected is your QL, that is equal to WT minus WP. Okay. Where QH is the heat transfer to the working fluid, QL is the heat rejected from the working fluid, that is from condenser, WT is the work transfer to the what? Work transfer from work done by the turbine and work input to the compressor, that is WP. So for the cycle efficiency we can write W net is equal to QH minus QL, or W net is equal to, you can say W net is equal to WT minus turbine work minus pump work, because work done on the system is negative, so WT plus minus of WP, that is WT minus WP. So from the cycle efficiency output by input, what is the output? Net work done. What is the input? Heat supply. So WT minus WP by QH, or you can say WT minus WP is equal to QH minus QL by QH, that is equal to 1 minus QL by Q. That is the efficiency of what? That is your heat engine. Okay. So first we will discuss Carnot cycle with vapor. Okay. So this one is your ideal vapor power cycle, which will follow the Carnot vapor power cycle, and this cycle has maximum efficiency operating between the temperature limit, that is your TH to TL. The Carnot cycle will be executed in the saturation depth for a dome for a pure substance. So if you have to draw the Carnot cycle for a heat engine, that is different, and here it will be Carnot cycle works on what? Vapor. So what will happen? Here the steam is the working fluid. So when heat will be supplied from the TH reservoir, Qn amount of heat will be supplied to the boiler, and boiler will convert the water into steam. Suppose you get here dry saturated steam or superheated steam. This steam will be expanded in the turbine. When it will be expanded, when it will be expanded, the volume will be increases, and the volume will be increases, and pressure will be decreases. Pressure will be decreases as well as temperature will be decreases. After decreasing temperature, from the exit of the turbine, what we get? We get is your wet steam. And this wet saturated steam will be sent to the condenser, where condenser will be reject the heat and it will be sent to the reservoir. And after losing the heat, the wet saturated steam, after losing the heat, it become what? Here in the condenser, it must be become your what? Liquid. But here in the Carnot cycle, the complete condensation is not there. Due to partial condensation, or controlled condensation at the 3 point or after the condenser exit, what we get? We must get the liquid, but after controlled condensation, because of controlled condensation, we got here wet steam. And this wet steam is again sent to the boiler steam having some specific volume, and that cannot be sent by the pump. So what we are using? We are using a compressor to compress the wet steam, where the dryness fraction is less. More amount of liquid will be there, less amount of vapor will be there. So that way we are using the compressor. So this will be compressed, and when it will be compressed, it becomes saturated liquid, and this saturated liquid or water will be sent to the boiler. So this way the cycle will be completed. Okay. So you can see here from where one point will be, this is your what, PV diagram. So in the PV diagram, so see, this one is your point 1. What is that point 1? Point 1 is a boiler outlet. Point 1 is your what? Point 1 is your boiler outlet. So from the boiler outlet, so this is your what? This is your critical point. So this line is your what? This line is your saturated vapor line, and this line is your saturated liquid line. So one point must be in the saturated vapor line, because we are getting the saturated vapor. So when it will be expanding in the turbine 1 to 2, isentropic expansion in the turbine. When it will be expanding in the turbine, the volume will be increases from V1 to V2, and pressure will be decreases from P1 to P2. So 1 to 2 is your isentropic expansion in the turbine. What is 2 to 3? 2 to 3 is your after turbine existed. The wet steam will be sent to the condenser because of controlled condensation or heat rejection. So 2 to 3 is your some of the heat will be rejected. So after controlled condensation, heat will be rejected. It become what? It become wet steam. And this wet steam is again sent to the compressor, where it will be compressed. Where it will be compress the wet steam, and it become what? Saturated liquid. And this saturated liquid will be again sent to the boiler. That is your we can add the heat Q in. So in the PV diagram, this is your what? This is your constant temperature line TH. Okay, and this is your constant temperature line, that is your TL, sink temperature. So condenser inlet and exit will be what? At the TL and the low temperature, and boiler inlet and outlet must be in the what? In the high temperature region. Okay, boiler in the high temperature region, condenser is a low temperature region. This way you can represent your 1 to 2, 2 to 3, 3 to 4. So if you draw the TH diagram, so this is your vapor dome. Okay, this point is your critical point. So 1 to 2 is your, what is the process? 1 to 2 is your isentropic expansion. So isentropic means entropy constant, that is 1 to 2. Isentropic expansion in the turbine. Then what is controlled condensation? 2 to 3 is your heat rejection. After heat rejection, the entropy will be decreases from 3. And then 3 to 4 is your isentropic compression. So after compression, S3 is equal to S4 is equal to what? That is equal to S3 isentropic. And then S1 is equal to what? S2. Isentropic expansion, and 4 to 1, that will be heat input in the boiler. So this is your temperature TH. This is your, so what we can say, this one is your constant pressure line. This is your constant pressure line P1, or you can say boiler pressure, and this one is your what? This one is your condenser pressure. You see that in the TH diagram, this is your constant pressure line. Okay, it will be boiler pressure to condenser pressure. So, decrease of in the expansion, pressure will be decreases from boiler pressure to condenser pressure. So if you draw the HS diagram, so this one is your critical point. So this line is your P1, this line is your constant pressure line P1, this line is your constant pressure line P2, or that is your P what? That is your PC. That is your PC, condenser pressure. So 1 to 2 isentropy, 1 point should be in the saturated vapor line. So 1 to 2 isentropic compression, so 2 point in the wet region. 2 to 3 controlled condensation, 3 point must be in the wet region. And 3 to 4 isentropic compression. After compression, 4 point in the saturated liquid line. Then 4 to 1 is your heat addition. 4 to 1 is your heat addition in the boiler, and 1 to 2 is your 2 to 3 is your heat rejection from the condenser. Okay, then processor 1 to 2 is your reversible adiabatic expansion or isentropic expansion. You can say that is your isentropic expansion. Okay, then reversible isobaric heat rejection in the condenser. Reversible isothermal heat rejection in the condenser. Reversible adiabatic compression in the compressor, Reversible isothermal heat addition in the boiler. So heat rejection, heat addition, isentropic compression and expansion. Okay, so these are the this is your PV, TS and HS diagram of Carnot cycle. Next we will discuss how we can derive the formula for thermal efficiency of the Carnot cycle.